So properties of quadratics. What the heck is a quadratic? Is this a quadratic?
No.
Nope, that's not a quadratic. Is this a quadratic? Nope. What's that? Anybody remember that one? That's an absolute value. Is this a quadratic?
Yes.
Yes. What if that's the very lowest spot? You know the name for that?
Origin.
Nope. The origin is this spot. That's 0, 0. The lowest spot right here, let's say it's at, I don't know, looks like 2, 1. That's called something. You know the name? That's what I'm supposed to teach you today, is all these little names for things. Nobody knows? I'll give you this hint. It kind of is the same as if you had like a triangle. This spot is called a something.
Vertex.
That's it. It's the vertex. And this is the vertex. The vertex is the one spot that's different than all the others. On a parabola, there's only one spot. That one lowest spot. But wait, what if the parabola is like this? Then it's not the lowest spot. What is it? The highest spot. It's either the lowest spot or the highest spot. That's called the vertex. Everybody, start taking notes. I want you to make this picture like I have. And I know it's not in your notes, but you can sketch a little parabola. It's not hard to do. The vertex is that lowest spot. What is this blue line called? I know you learned it at one point. It's about how it's the same on both sides. It's kind of like you have one down the middle of your face. A line of what?
Axis of Symmetry.
Symmetry, yes. And it is called the Axis of Sym. I'm not going to make you spell it all the way out. You never remember the spelling anyway. Axis of Symmetry. Copy this. If you don't write it, you won't remember it. You'll remember 10% of what I said, which is not much. If I tell you 10 things, you'd remember one of them. All right, Axis of Symmetry. Now, I had a kid who said something dumb and it stuck in my head, so I think it's pretty smart, actually. They called it the Axis of Symmetry because it's always x equals something. In this case, it's x equals 2. Do you get where I got that? It's from the vertex. It's the x of the vertex, so it's the Axis of Symmetry. There's still a couple cell phones out. Put them away. They cannot be on your desk at this time. And not in your lap either. All right. So the axis of symmetry runs right down the middle. The vertex is the lowest spot. How about this spot right here? I'm putting a bright green dot there. It's a special spot. Anyone remember what it's called? Hint. This is the x-axis and this is the y-axis. Yes? The y-intercept. That right there, y-int. Take notes. You're not taking notes, take notes. That's the the y-intercept. Now this parabola that I drew doesn't even touch the x-axis. Do you get if I had made it upside down, it would have? Then these spots are called x-intercepts. They're where it hits the x-axis. This original guy, he doesn't have any. Doesn't touch. But these would be x-intercepts. It's where it hits the x-axis. All right, we're almost done. One last thing. Some kids are better at this than others, but on the right side of the axis of symmetry is different than the left side. Do you get that this parabola is not always increasing? It's only sometimes increasing. How do you judge if something's increasing? Would you agree if I bought Tesla stock and then the Tesla is going up, it would have seemed like, oh, that's increasing. Does that make sense to you? Okay, so in this zone right here, the green zone, you probably can't even see that because it's dark in here, so I'm going to make it red. This pinky kind of color, do you get in that whole time? It was increasing. From the middle to the right, that's increasing. How do I say that's increasing? With an interval. And this is the last thing you have to learn. Pay attention here. The interval where it's increasing is from 2 to infinity. I want you to think about that for a minute. It was the x of the vertex. You see how it's all around the vertex? The vertex is involved in pretty much everything. It's kind of like the principal at a school. The principal is like, he's like the key to almost everything here. Mr. Erickson. He's on all these different committees. He hires all the teachers. He can fire the teachers if he wants to. I mean, it's not quite that simple, but he can try anyways. He can start the process of firing somebody. The principal is like the key, or at least one of the big keys at the high school. Well, the vertex is the key. It's got the x of the vertex here, goes right there, and that it increases from 2 to infinity. Then what's it doing? Watch me when I highlight this. What's it doing here then? What's it doing? Say it. Wasn't that going down? That was decreasing. That whole zone, it was decreasing. It was decreasing from negative infinity. And a lot of you are going to be like, what the heck? It's way up. How is it negative infinity? Until it stopped decreasing at this point, which was the 2 again. Well, here's the way I want you to understand this. From here to here, in the blue zone, it was decreasing. In the red zone, it was increasing. Do you get how the borderline is right there at the 2? So this is where positive infinity is, right? Do you get how that's where positive infinity is? What's way over here, right here? What's right there? That's where negative infinity is. So that's why it's decreasing right here until it hits the 2. So that's from negative infinity until 2. Now, I know that's the hardest part, and that's the hardest part to teach, and it's the hardest part to learn. So I want to practice that part again. So everybody, make me one more of these things. It's going to be an upside down one this time. And its highest, ooh, that was pretty bad. I'm going to try again. And its highest spot here is going to be at negative 3, 1. Why is that so important? It's like the principal. It's involved in everything. It's involved in the axis of symmetry. It is the vertex. It's got one of the numbers for the increasing and one of the numbers for the decreasing. All right, so that's the vertex. What's the axis of symmetry here? I know it's this dotted line, but how do you say that dotted line? Don't say it out loud. Would you please label it? And in a moment, I'm going to ask you to turn and zoom in on your answer. Like, let's say you think it's y equals negative 5 or something. It's wrong, but let's say you thought it was that. Zoom in on it, and then show it to your neighbor and see, what do you think the axis of symmetry is? I'm going to pause for a second. Well, you compare with the kid next to you. What's the axis of symmetry? How many of you knew it was x equals negative 3? Raise your hand if you did. All right, if you didn't know that, do you get it was the axis of symmetry? You know, the axis of symmetry, the axis. It's got an x in it. It always does, every single time. It'll always be x equals something, okay? And how about this spot down here? What's the name for that? That's the y-intercept. How about these two green spots? I'm putting a green dot there. X-intercepts. That's where it hits the x-axis. And last but not least, this parabola is only increasing half the time, and it's decreasing the other half the time. If you were riding the roller coaster, you'd be going from left to right. Would you be increasing first or decreasing first? Say it if you know it. Increasing. Now try to figure out, this is the hardest question. What is the increasing interval? It's not like super hard once you know how to do it, but that question will get marked wrong on the test a bajillion times. The increasing interval. Then if you get that, you probably can get the decreasing interval, which is when the thing starts going downhill. Remember, these are x values. If you're flipping a coin between the x and the y, the answer is usually x. If there's a most important point, it's the vertex, because it has the axis of symmetry in it. Remember, that was x again. It was the x of it that was important. So in these increasing and decreasing intervals, remember that the x is the important number. All right, I'm going to pause while you try to write the increasing and decreasing intervals. You guys are recording. Okay, so I'm going to give you a hint. Way to the left here, that's where negative infinity lives. Way to the right here, that's where positive infinity lives. And since the increasing and decreasing intervals are about x values, these are the two you should be thinking about. Negative infinity and positive infinity. So Corey, what do you think the answer is for the increasing interval?
Negative.
Negative infinity, keep going.
And just
When does it stop increasing?
does.
It does. It stops increasing right there. Think if you were in a roller coaster and you were riding it up, at that exact moment at the top, you stopped increasing. Give me your final answer.
Negative.
That's it. Raise your hand if you had that one. Negative infinity to negative 3. Okay. This is hard to get across, so thank you for trying with me. All right, now the decreasing. At that moment, your car starts to speed up and you go down the hill. And it's from where to where? Well, negative 3 to goes way over here. It keeps going forever that way, so positive infinity. There's your two answers. Notice they use x values and positive and negative infinities. Yes?
Wait, why would it be -3 and not 1?
Because it's always the x values. I knew somebody was going to be thinking it was 1, but it's not. The question isn't how high did it go. If that was the question, the answer would be 1. But the question is, when was it increasing? And x values are like time. Has anybody ever told you that x's are like the time? X always goes this way and time always goes this way. So it's like the time that it was increasing, which was from this to this. And then from this to this, it's decreasing. So from the time of -3, I know time being negative is a little weird, but all right. So let's go on with the actual official definitions. The vertex, the lowest or the highest point on the parabola. You write it as a point. Does that make sense so far? The x-intercepts, the point where it crosses the x. And this is important. The x-intercept is where y equals 0. I'm going to say that again. The x-intercept is where y equals 0. Now try to figure out what I'm going to say next. The y-intercept is where what? X equals 0. See right here, the y-intercept, x is 0. If you can get that through your head both ways, the x-intercept is where y is 0, and the y-intercept is where x is 0, that would serve you so well in this class and in pre-calc. That comes up a lot. We got to get our basics like that down. The x-intercept and the y-intercept, or where the opposite thing is 0. X-intercept, where y is 0. Y-intercept has x is 0. All right, and last but not least, the axis of symmetry. An imaginary line that cuts the parabola in two symmetrical, line of symmetry, you know, two symmetrical halves. It must be written as x equals, I called it the axis of symmetry, you remember? Because it's a vertical line. So this has a dotted line right down there. Most of you would have been able to pick that out like instantly. Your brain just knows that's the line down the middle. But what's the equation for it? Everybody figure out, I'm going to give them different colors. The black dotted line, figure that out. Figure out what the blue point is. Figure out what that orange point is that they gave you. It was on the Y, by the way. Then there's these two red points. Find those. And that's pretty much it. Those are the key spots. The red spot, the orange spot, the blue spot, and the black dotted line. Give them names. Be prepared to be called upon in just a second. I'll pause for a second while you give it a try. Okay, here's the answer to the questions. This spot, 1, 0, that's the x-intercept. And this spot, -5, 0, it's the x-intercept. Notice, the x-intercept has a y of 0. See? X-intercepts, y is 0. This orange spot, that's called the y-intercept. And that's at x is 0. 0, -5. Okay, this spot here is called the vertex. And the vertex was at -2, -9. And last but not least, the axis of symmetry. X equals -2. How many of you had at least 3 of those things correct? At least 3 of them. Okay, good. Then I think you're generally getting this. This is good. All right. So to write the x-intercept properly, just the key here is you always put what equals 0? If it's the x-intercept, what is 0? Y is 0. You always put a 0 there. Okay? And so if we're talking about this x-intercept, I would say it would be at, that one there would be at -5, 0. And that one there, that one would be at 1, 0. If it's an x-intercept, the y is 0. Okay. Any questions about x-intercepts? Come on. The dotted axis of symmetry. What's it always going to start with? X equals. And then depends on what the line is at. This line's at -2, so I'd say x is -2. All right. Increasing and decreasing intervals. I screwed this one up in the other hour. Let's see if I can not screw it up this time. Would you agree the vertex is not that orange point? That's what I screwed up the other hour, is I thought the vertex was 0, -15. It's not. The vertex is actually what, what? Somebody be smarter than me last hour. -1, yep, -1, comma. How low does it go? -16. There you go. You're all smarter than me last hour. Okay, so there's the vertex. And now, where does it increase? You can always put 2 parentheses and a comma. Where does it decrease? 2 parentheses and a comma. And remember, this is always about x, so I like to draw it like right here. And it's from here over, and I'll make the other one blue. It's like the blue one and the red one. The blue one's where it's decreasing. You know, it's going down in that part. The red one's where it's increasing. It's going up during that time. So the blue one is one of them, and the red one's the other one. See if you can answer these two. In a moment, I'm going to see if you got the same thing as a kid next to you. Try to be as smart as them, or smarter this time. I'll pause for a second and give that a try. So I'm hoping you got this now. But I also get it might take another day or two. We'll keep reviewing it. But as if this was a roller coaster, you would be going extremely fast. And would you be increasing or decreasing at that point? Up to there, you'd be doing what? Decreasing. Okay, and that was from -infinity to the other end of it, which was the x of this. Remember how it's all about the vertex? It's the x of that, so it's -infinity to -1. Wait a minute, that was, I just said decreasing and I wrote it in the increasing spot. Negative infinity to negative 1, there. Now the increasing is where it starts going up again on the other side. If you were riding a roller coaster, right there is when it starts, it'll slow down, but it's still increasing its height, okay? And that'd be from negative 1 to, what's way over here? Infinity. I'd be fine if you wrote INF or an infinity symbol. All right, so you've learned everything that you need to know. Everybody open up the worksheet on this. It's a Schoology quiz. Find the Schoology quiz and open it now. I'll be able to tell if you're not in there, so please save both me and you a little bit of pain. You're just opening it immediately. It does not have a timer on it. It is resumable, but I want you to start right now. And that's also, I'm going to be handing back the tests in a few minutes, but I want everybody to be starting the worksheet first. And that's all I got for the video for today.